Good day, viewers. You're welcome to Soluble Tutors. Now, I'm making this video to explain to you what you need to know in chemistry to be able to have more than 300 in Jamb. Now, in chemistry, there are 18 major topics. There are 18 major topics that you must really understand if you want to pass Jamb, and you have to have more than 300. And today, I'm making a video now to explain the first topic because we have 18 major topics, and this is episode 1. So I'm explaining the first topic here now. So now the first topic is this: separation of mixture and purification of chemical substances. Okay, so in this video I will explain all the separation techniques you need to pass your Jamb and WAEC very easily. I will explain all the separation techniques starting from hand picking, magnetization, sublimation, sieving, decantation, filtration, centrifugation, evaporation to dryness, crystallization, precipitation, using separating funnel, distillation, chromatography, and the likes. And you will never regret ever watching this video. I will advise you to watch to the end, and you will see that it is very easy for you to understand chemistry and pass your Jamb gallantly. So how can we separate mixture and how can we purify substances? Before I go in depth into each of them, I would like to explain to you some clusters. Some clusters that will make you to understand it even better, because there are ways in which the thing emanated and being generated. How do we do that? The first one is this: I will categorize the separation techniques. What you want to separate, I will categorize it into different categories based on the state of matter. You know, we have different state of matter. Okay, now we have solid to liquid and liquid to gas. Those are the state of matters. So I will use that to explain to you in total of what you have to do. Now, the first thing I will have to say is this: we can have solid in solid. That is the mixture of solid and solid together. How can you separate them? There are properties of those solid that will guide you in a way for you to be able to separate them correctly. You might try to separate based on different qualities. There are two solids on ground, you can identify them. Let's say, for example, we have beans and we have rice. If you have to separate them, you can be hand picking the beans because of the quality. You know the color of the beans, you know the shape of the beans. So it means the first one is what? Hand picking. Hand picking is a separation technique in which we use to separate two solid mixtures based on their differences in qualities. Based on their differences in qualities. That's number one thing. Another thing is this: magnetization. That's another separation technique. Magnetization. From the name, you should be able to understand that this one deals with magnets. When you talk about magnet can only catch magnetic materials. Let's say, for example, you have your key, iron key, metal key, okay, or let's say metal bolt dropped into the soil. Soil is not magnetic. You can put your magnet and roll it about. Before you know it, the magnet will pick those magnetic material. By that, you have separated it. Now, how can we define this? Magnetization is the separation of two solid mixtures, okay, whereby one of them is a magnetic what? Substance. So it will separate the magnetic substance from the non-magnetic substance using magnet. That's just using magnet. Now, sublimation. How can we go about sublimation? Sublimation method comes from the name. When something sublimes, what does that mean? Sublimation is when matter translates from solid directly to gas, instead of matter to come from solid to liquid to gas. So the solid comes directly to gas. That's sublimation. It has skipped a stage. Now, there are some solid that sublimes. So if you now add them together with other solids that cannot sublime, you can use sublimation. What are those solids that sublime? For example, iodine is one of them, sulfur, ammonium chloride. So if any of them are now added to a solid that cannot sublime, maybe like sawdust, like wood, like sand, any other thing. So what will you now do? You now put them on the what? Put them into the pot and try to put heat. You fire them. When you are heating it, you heat in something like a test tube, and you have to collect it. I will still go into the details of that. Okay, sieving is very popular. We use it in garri mill, we use it in mill. What does sieve means? Sieving means we go in the property of solid based on their differences in particle sizes. Some have a big particle size, some have small particle sizes. So the mixture of the same solid is the same type of solid, okay, maybe in powdery form, but one of the solid is what? Is big, has a big particles. One has a small particle. For example, You can take your cassava flour, you can take any other thing, you put it on a sieve. We are using sieve now. That sieve will now have a mesh size, whereby the smaller ones, those ones with smaller particles, can pass through. The ones of bigger particles will stay on the sieve. By that, you have separated it, the bigger one from the smaller one. Okay, now let's go to the next one. Everything I've said now is dealing with solid in solid. Let's now go to solid in liquid. Talking about solid in liquid, now there are two categories under that. The first category is this: insoluble solid in liquid. Some solid, we put it in liquid in order for us to give us solution. They will not give true solution, they will not dissolve, because solid is a solute, liquid is a solvent. Solute plus solvent gives us what? Solution. Now they will not give us a true solution, they will not dissolve. Some of them will not dissolve. How do we now separate such? That's what we bring about, because out of solid in liquid, we have insoluble solid in liquid, and we have soluble solid in liquid. But talking about insoluble solid in liquid now, how do we handle that? The first one is decantation. Decantation is when you are pouring, you are trying to pour those ones that are suspending. Okay, some solid will not dissolve and will be suspended. You can now pour it gradually, gently into another container. That's decantation. Though it's not the best method of purification, but at least it's not the best method of separation, or we call it purification, but at least you can use it also. Okay, decantation. So you just do it and you use your steering rod to polish it, so that that solid will not what? The other one will not pour away. Some solid will just sink and settle down, so that you can now pour the liquid on top of it. Okay. The other one is filtration. Filtration and decantation always go hand in hand. Most of the time when we want to filter, we also use what? Decantation. Okay. So decantation is the separation of what? As insoluble solid in liquid, whereby we pour it gently. Now filtration, we use filter paper and a funnel. Now you have a funnel, we have a conical flask most of the time, and we can have any flask. We now put a funnel, we now put a filter paper in the funnel. Alright. Now after that, we now decant into that particular funnel with the filter paper. When we decant, now what we are decanting is not pure, it still has some remnant of the solid. So the filter paper will not take that. What we have in the filter paper is called the residue. What we have in the conical flask is called the filtrate. So we can now hair dry or oven dry anything in the filter paper. We have gotten back our solid, and our liquid is what is called the filtrate. Okay. Another one under that is centrifugation. Centrifugation means when you spin. Okay, we have a machine called centrifuge. So we put our sample in the test tube. We now put the test tube in the centrifuge. It now spins. As it's spinning, based on gravity, the insoluble solid will now move towards the last edge, the bottom of the test tube. And after it has spun for many minutes or hours, you take it out and you can see that it has separated. They use this one to separate blood before any analysis on it, any test on it. That's about insoluble solid in liquid. Let's go to soluble solid in liquid now. Soluble solid in liquid. How do we go about that? Okay. The first one method under that is evaporation to dryness. Now let's take an example. You put your salt in water. Salt dissolves completely. How can you now separate that? Something you cannot see again that's dissolved. To separate it, you put it inside the evaporating dish. You now put it in a water bath. Water bath means you have to put another container, put water there. It is that water that you start heating up. As you are heating it, it is the steam of the water that will now heat the container that contains your mixture. So that there won't be direct heat, so that it will not spoil the solid. Because if there is a direct heat, after it has evaporated, it will burn the solid and it will change the composition, which means you have not separated. So that's why we use water bath. That one we have to put it on fire, make sure that every solvent or liquid has evaporated. This one also has a drawback because we are going to sacrifice the what? The solvent. Okay, so that's the separation of what? Of soluble solid in liquid, whereby we evaporate the liquid so that we can get the solid. The other one we have is crystallization. Under crystallization, we have simple one, we have fractional crystallization. Now, crystallization is when your solid has dissolved in the liquid properly, normally, and you have to separate it. How will you now do it? You also heat it up. You heat it as if you are evaporating it, but you won't allow all the solvent or all the liquid to evaporate. Okay, after it has evaporated for some time, you leave it alone. Now, those solids will now coalesce together and solidify. You now see it as a crystal. Crystal means solid that still has some water in it, and you see it that will be shiny. Okay, so that's crystallization. Fractional crystallization means you have to take more than one solid. You have more than one solid in the liquid. So you now take it step by step. That's fractional crystallization. We also have precipitation. Precipitation is when your solid has dissolved in your liquid, but you now introduce another liquid that one of those mixture of the solid will not dissolve in it. So when the one react together, they now form a what? A precipitate, which means solid in liquid. Solid that comes out is called what? Precipitate. That's that about that also. Okay. Let's go to liquid in liquid now. That's the third, because we have done solid in solid, solid in liquid. We are now going to liquid in liquid. There are two categories to that also. Some liquid are not miscible. For example, kerosene and water are not miscible. Okay. Palm oil and water are not miscible. Petrol and water are not miscible because all those ones I've mentioned, that organic solvent, they cannot mix with water. How can we now do it? When we put them in the separating funnel, because that's the number one method, and that's the only method used for immiscible liquid. Immiscible liquid means you will now see the level. You see the level in the separating funnel, so you can now open the tap. After opening the tap, we can now separate it in that manner. So that's the method we always use for immiscible liquid. Now, let's now look at under it. There we have miscible liquids also. When I'm talking about these miscible liquids, we have the first one, distillation. That's the method. We have simple distillation, we have fractional distillation. Distillation, how do we go about that? Distillation means you are vaporizing, some people call it evaporation, and you are still now cooling it down from gas. The thing is coming from liquid to gas, goes through the chamber, now goes through the Limber condenser. Condenser will now cool it down. We now turn the gas back to liquid under a certain condition of temperature. We have to monitor the temperature based on the boiling point. Based on the boiling point of the liquid. So we have different boiling points in terms of the liquid. Okay, let's say for example, ethanol and water. Ethanol have boiling point of 78 and water has boiling point of 100 degrees Celsius. So you'll be monitoring it. When you eat, we are heating the mixture up, you get to the temperature of 78, between 78 to 80. You leave it like that until everything now turns back and condense into liquid. What you have collected then is ethanol. You later heat it up again to get to 100. Anything you collect at that time will also be water. So by that time you have separated. Okay, we also have fractional distillation, which you can use to separate miscible liquids of close boiling points. The properties we use in that manner is changing in the difference in boiling point. Now, since I've said all these clusters, we also have chromatography. After I've mentioned all these clusters now, what I want us to do now is to go to the book, please. Let me also take you all to the books because I still have some other things I have to explain to you. So let's go there and enjoy it. Thank you. Let's go there now.
Now, checking through the books, I want us to complete everything that deals with the separation techniques and everything. So matter and separation techniques, as you have it here, we all know the definition of matter. Okay, that matter is anything that has mass, okay, and occupies what? Space. You understand what we have there. Now, the next thing we have to do now is go to properties of matter. We know that. Let's go to the physical properties. Physical properties of matter. Okay, in the physical properties of matter, we say they are associated with physical changes. What are the physical changes? Boiling point, okay, melting point, density, hardness, malleability, crystalline form, and other things like that. Okay, that we can mention of things like that. So what other things do we have under there? We have chemical properties. Chemical properties means when something is rusting, burning of firewood, addition of water to quicklime. Those are the examples. Now, homogeneous and heterogeneous mixture, we must have heard of that before. Jamb can also ask and WAEC can ask us. Homogeneous and heterogeneous mixture. Now, homogeneous mixture are called solution. Okay, they are called solution and occurs in single phase. So we have to be very careful. They are solution, okay, and they occur in single phase. You can see there, which may be gaseous, liquid, or what? Solid, iron, copper, and things like that. But when they are homogeneous, please, they are peculiar to single what? Single phase. You have to be careful. Single phase. That's the major thing there. Single phase. Heterogeneous mixture consists of more than one phase. You can see more than one phase. So if you want to define that, that's what we go there. Okay. Single phase. That's homogeneous. Heterogeneous is like our mixed mark, which has double phase. You have to shake it before you use it. They are not evenly distributed. Types of changes. We have physical change and we have chemical changes. It's under your syllabus in Jamb and WAEC. What are the physical changes? Okay, physical changes, this is one which is easily what? Reversed. We have to be very careful. This is a point. It is easily reversed or easily reversible, and in which no new substance, new substance, very important. New substance. No new substance are formed. So there are two things you have to mention there. Easily reversed and in which no new substance are formed. Very, very important. Okay. Example of such changes include, you can see a lot of examples here. Okay, if I'm too fast in this video, I don't want it to be too long. Please, you can pause and you jot down properly before you can play again and you continue. Please, you can pause. It's very, very important. We also have chemical changes. We have discussed about physical. So chemical changes, we have said that chemical change is a transformation in which new what? New substances is formed and is not easily reversible. Those are the two things we have to mention. New substances are formed in the chemical change and it's not easily reversible. Just like your garri and hot water, you know it will form eba. Now the new substance and it's not easily reversible. We have a lot of examples under that here. A lot of examples. Okay. When you burn wood into ashes and gas, we all know that we cannot take it back. It's not easily reversible. And it has had another name, ash and gas. Okay. Fermentation or decomposition, we cannot take it back when anything ferments. When we burn magnesium in the presence of air, nothing we can do to that. So anything that deals with chemical like this, it cannot be changed. Those are what chemical changes. Now let's go to difference between physical and chemical changes. What are the difference? From the definition, the first one, it is generally easily what? Reversible. This one under chemical change is generally not easily reversible. Okay. So we go to number 2. Produces new substances. Okay, it produces new kind of matter. That is, it means it produces new substances. And we go to the other one, chemical changes. That's the number 2. Always produce new kind of substance. I made a mistake there, sorry please. Physical changes produces no new kind of substance. That's a mistake there, please. Physical change will not produce new kind of substance, and the chemical change will produce a new kind of substance. So let's go to the number 3 there. There is no change in mass of substance. Mass will not change. Just like your garri and water, it will not change mass. It will not be more heavier than before you prepare them. But the other one, there is change in mass of substance. Your eba will be heavier and the mass will change. Okay. Number 4, under physical change, no great heat change. Under physical change, sorry, no great heat change, and under chemical change, a great deal of heat change. Okay, and that's that about that. So let's go to the next one. On the next one, they spoke about compound and mixture. Now, when you're talking about compound is what you get after chemical change. Anything you get after the chemical change is called compound. These are examples of compound and they must be in a fixed mass ratio. For example, H2O will always be H2O. If it's not H2O, that's not water. It means it's in fixed proportion. Fixed proportion. That's what the law of fixed proportion told us. Okay, constant composition and fixed proportion. Okay, now we can check this one out. You can pause this video or you look at your textbook to have further knowledge about it. So let's go to mixture. Talking about mixture, a mixture contains two or more constituents which can be easily separated by physical means and can be easily reversed. Compound substance formed when two or more different elements are chemically joined together. Okay, that's the definition over there. That of mixture, it is when they can be physically separated or they are joined by physical method. That's very okay there. Now, differences between mixture and compound. What are the difference? Now, in terms of mixture it may be homogeneous or heterogeneous, that it can have single phase or more than single phase. But compound, it is always homogeneous. It is always homogeneous. You can see it there. Under mixture, the constituents are easily separated by physical means. Okay. In compound, the component elements are not separated by physical means. Cannot be easily separated. You can see that. Number 3, a mixture cannot be represented by a chemical formula. Yes, water is a compound. You can represent it as H2O. But mixture, how can you represent it? You cannot use chemical formula to represent, but you can use it here. So number 4, the properties of mixture are the sum of the individual constituents. Yes, if you take your garri and water, garri will still be garri, water will still be water. They still maintain their what? Their composition and constituents, okay, individually. But when you are talking about compound, it will now form new single constituent in terms of the compound. All right. So now, I've mentioned all this one before in the beginning of our video. Types of substitution techniques. What I want you to do now is to look at it thoroughly. You can pause this video and check it thoroughly, please. Okay, look at sieving. I've mentioned what you needed. That is, we have different particle sizes, you can see, and the sieve itself, it has a mesh size. Those are the little things you have to put in your brain. When you are explaining, you have to mention them. Okay, look at magnetic separation also. It's also of solid and solid. This method is used to separate magnetic substances from non-magnetic particles or substances. Is it not very simple? Very simple. So now another one, sublimation, as I've mentioned and explained before. This method is used to separate solid which sublimes on heating. You can see now, I've mentioned that before. And let's rush down like that. So this is the diagram I showed to you the other time on the video, and I explained that properly. So we have fractional distillation. You can also pause this video, pause it and watch it properly and make sure you understand it. You can pause this video and try to watch everything that is here, read it and make sure you understand it thoroughly, please. Let me go to the next one. Now the next one is the continuation of this is a fractional distillation. Okay, this is fractional distillation. This is fractional distillation, you can see it there. And this one is the separating funnel. I told you what we use separating funnel for immiscible liquid, miscible that are not miscible. So this method is used to separate immiscible liquid. You can see those are the things you must be mentioning, such as petrol and water, because they are non-polar and polar solvent. I told you one is organic. The one that is organic is the what? Is the one that is organic is the what? Is the non-polar, and water is the polar solvent. That's what we always say, please. So after that, we have the chromatography. This you have to read it by yourself and make sure you understand it. You can pause the video here and read it thoroughly. You can see what is written there. Read it very well, or you go to your textbook for further reading. Now, this is the continuation of the paper chromatography. Okay, this is just the explanation. After that, we go to decantation, which I've explained thoroughly. You can see decantation is the pouring away, I mentioned that, of liquid from solid, insoluble solid from liquid. And you can see the diagram over here. This is the diagram. You can pause this video and watch it, and you take your time. You can see filtration. We have filtration there also. You can check it thoroughly, read it thoroughly and make sure you understand. Okay, so let me go back and let's see, maybe we have one more page. I think we have like two more. So this is the continuation of decantation. This is centrifugation, as I've mentioned earlier in the video that I did. This is centrifugation. You can go through that and understand it properly. I explain everything about centrifugation. Okay, also evaporation. This is evaporation. You can also read it and understand and master it properly. Okay, and after that we have crystallization, as I've explained. Make sure you read it, pause this video as I've said, read it thoroughly, or you check the textbook and things like that. We have fractional crystallization also. Precipitation, I also mentioned that. You can take your time, pause this video and read it. Let me go to the next one now, because I don't want this video to be too long, so that's why I'm trying to rush. The next one over there, we have distillation. You have seen fractional distillation before. Now the next thing I want us to talk about is pure and impure substances, please. Now test for purity. We can test for purity in liquid, we can test in solid. When it's in liquid, we look at the melting point. When it's in solid, we look at the melting point. What does impurity does? Impurity lowers melting point of solid. Let's take shea butter for example. Shea butter is hard, in room temperature is hard. If you add any oil or anything to shea butter, it will dissolve, which means you have now lowered the melting point to that of the room temperature. So that's how to know. So impurity normally will lower the melting point, whereby impurity will now increase the what? The boiling point. It plays a very key role. It will increase the boiling point. Let's take for example water now. Water has a boiling point of 100 degrees Celsius. Anytime you are heating it and use your thermometer to test it, and water did not boil at 100 degrees Celsius, it boils above 400 degrees Celsius, it means that that time the water contains impurity. Look at this for example. This is ethanol with 78 degrees Celsius. Okay, whenever you now heat it up and it doesn't boil at 78, it boils above 78, it means there is an impurity there. So I don't want this video to be too long. It's long already. Thank you and God bless you. See you in the episode 2. This episode 1, we have 18 topics to cover in the Jamb for you to do very well. Please try to check my channel. You will see the other episode. Thank you and God bless. I really appreciate everybody. Thank you. God bless.